Let us do it using the Runge-Kutta two-stage method. Okay, the Runge-Kutta two-stage method. And this approach, Runge-Kutta two-stage method. Okay, the two-stage method. And this approach we will do the following. So this is time. That is the solution axis. Let's say this is the solution that I want to find. Okay. What we are going to do, this is the initial time, t0. That is, let's say, t1. Okay. And this interval represents the step size or the time step. Okay. In the Euler's method, we took the slope only at the initial solution. Over here, in the Runge-Kutta the two-stage method, we will take the slope at the midpoint of the interval. So basically, I will come in the middle part of the interval, h/2. That is h/2. I will calculate the slope over there as well. Okay, so the Runge-Kutta two-stage method says the new solution equals the old solution plus certain weight multiplied by slope 1, which is basically that is slope 1, plus another weight multiplied by slope 2. Okay, that is slope 2. So what are these weights? This is the contribution of the two scientists. So we have K1, which equals h multiplied by the function evaluated at t and y. Shabab, this is basically what? What was that?
That kind of time steps.
That was the first part of Euler, right? Euler said yi plus 1 equal to yi plus h multiplied by fti yi, correct? That was Euler. Okay? And K2 equals h multiplied by the function evaluated at the midpoint at t plus h/2, comma, y plus k1/2. So every time in the function that you have t and you have y, just replace them by t plus h/2 and y by y plus k1/2. Okay, and the Runge-Kutta two-stage method says that the new solution I plus 1 equals the old solution plus k2. That is, by the way, that is what is known as Runge-Kutta two-stage method. Okay, that is Runge-Kutta two-stage method, and Shabab, this approach is second order accurate in comparison to Euler's method. Okay, let us just do it quickly over here. Let us do it manually. Over there. I can just add more space. So guys, let's do the same example. the same example. Y prime plus 4y minus t square equal to 0. Initial condition y at 0 equal to 1. Let's use the same time step 0.1. So what shall we do? What shall we do? Define the slope on the left hand side and all the other terms on the right hand side. So, okay. And this is the function of t and y, which is the slope equals to t squared minus 4y. Okay. So now let's create a table. In this table, I have the following. I have I, T, Y, K1, and K2. Okay. Okay. Guys, initially, the first iterator, T was 0 from the initial condition. Y was 1, again from the initial condition. Okay. What about K1? How to calculate K1? Remember, K1 was H multiplied by the function evaluated at T and Y. Yeah? So how much is that? 0.1 times the function. What is the function? That is the function. Here, 0 squared minus 4 times 1. Correct? The answer over here is minus 0.4. What about K2? K2 equals H multiplied by the function evaluated at the midpoint of the interval, T plus H over 2 and Y plus K1 over 2. Okay, so let's see how can we do that. So over here, it is 0.1 multiplied by the function. What is the function? That is the function. Rather than t squared, it is t plus h over 2. So let's say 0 plus 0.1 divided by 2. The whole thing is squared, t squared minus 4 times. Rather than y, it will be y plus k1 over 2, which is what was y initially, 4 plus what was k1 minus 0.4 divided by 2. How much is the answer for that?
طلع لي minus 0.319.
Minus 0.311. Anyone who can confirm this?
975.
No?
1 واحدة بس دكتور بعدين 975.
Okay.
ايوه.
All right. Let's go to 2 now. How much is the time at the next time step? Yeah? How much is y now? The new solution. So the new solution equals the old solution plus K2, correct? That is the scheme. So that is equal to 1 plus K2. Where is K2? That is K2. Let's take this value over there and plug it over there. Minus 0.3197.
0.6803.
0.6803.
03.
Anyone else who can confirm this number? Okay, so let's continue over there. Let's continue over there. Let's calculate K1 now. K1. So K1 equals H, which is 0.1 multiplied by the function evaluated at T and Y. What is the function? T squared, channel T squared, 0.1 squared minus 4 times what? 4 times Y. What is Y, guys? That is Y. 0.6803. Okay? And the answer is something like that, or whatever. Then K2 equals H 0.1 multiplied by the function. What is the function? The function evaluated at T squared T plus H over 2 اللي هي 0.1 plus K2 اللي هي ما حسبناها هنخليها هني over 2, the whole thing is squared, correct? Minus 4 times Y. What is Y? You replace Y by this Y, 0.6803 plus K1 over 2. طبعا ما حسبنا K1 over 2, and that is K2. What we are going to do with K2, I'm going to use this information, 0.1 plus 0.1 اللي هي 0.2 will Y equals the old Y 0.6803 plus K2 اللي حسبناها يعني. Okay, I will use that K2 and I'll put it there. Then I will calculate K1 and K2. And I will use this K2 and the new solution, and I will use this. I will use the old and do. I will use the old solution over here, over there. So Y plus K2. واضح البروسيجر؟
واضح يا دكتور.
Okay. So how can we do that manually in MATLAB? Again, manually. Let's calculate. Define t equal to 0, y equal to 1, the function, and h. Okay, we have all that stuff, and then we will say that y. We will calculate, let's say, K1. K1, what is K1? H multiplied by the function evaluated at T and Y, and K2. H multiplied by the function evaluated at T plus H over 2, comma Y plus K1 over 2. Okay. And then the new solution equal the old plus K2, and then you update the time, T plus H, and then you just present Y and T and Y. I hope I did not miss anything. Yep, we calculated that, right? 0.608. And maybe, guys, maybe we can put it in this comma in order to see some part of the output. Okay, so that is the solution at this time step, that is K1 and K2. Okay. This manual approach is not recommended. It's just to see what's happening and how to advance the solution. Let's go to the same script that we created earlier, and guys, tell me, what do we need in order to modify this code now.
دكتور نحسب K1.
Okay, K1 equals H multiplied by the function evaluated at T and Y, and K2 is H multiplied by the function evaluated at T plus H over 2, comma, Y plus K1 over 2. Okay. What else?
Y equal Y plus K2 صير.
Okay, so Y equal to 2. Okay, what else? Anything else?
أتوقع أوكي ما
Okay, so let us run this section now. Okay, maybe we can plot it as well. Plot. Okay, run this code. Something went wrong. Let's clear everything. Okay. Okay, maybe as well we can yep. So can you follow it, guys? This is the difference between Euler's method and the Runge-Kutta two-stage method. The only difference is adding the other weights and the slopes. We are adding more weights and taking an extra slope in comparison to Euler's method. But yet, this is much better in terms of the accuracy. Next time, Shabab, we'll answer more questions, we'll solve more problems, and we can compare those approaches together. Do you have any question regarding what we presented today?
Doctor, I had a question, not
Yeah.
about today's lecture, but I was talking about the midterm papers. Is it possible to show us like the corrections of the?
Sure. Shabab, let's have. We'll decide. Okay. First of all, we will have a quiz on next week, right?
Right.
يا دكتور.
Sunday, صح؟ قلنا؟
صح.
Okay, خلاص. Okay, this is first. Second, next week, inshallah, I will put a time and date so you can come on campus, come to my office to see your paper. Fair?
All right, Doctor.
Okay, so we'll decide it next week, inshallah. On Sunday, we'll talk about that. If I forget about it, just remind me about fixing the time.
Okay, Doctor.
خلاص خير ان شاء الله. See you inshallah next week.